the circle graph below, describing his time spent at school in day one. The teacher said that the number of hours listed was correct, but that the central angle measures for the sectors were not correct. What should be the central angle measure for the core subject sector?
Okay, and notice I underline core subject, which is this part. There's core, there's electives, there's lunch and passing time and choir. We don't get that much time for lunch. I guess if we added all the passing time alone, maybe it does come out. Okay, so the minute you see a problem where there's a circle and a dot at the center, you're going to think 360, right? Okay, how many hours total was Antoine at school? 9. Core subjects was what fraction of that? Beautiful, 4/9, right? 4 hours, and the 9 for the total day. And they want the central angle. So if this piece, think of this as the area, this is 4/9 of all the area, then this angle here has to be 4/9 of 360. Right, write it down. 4/9 of 360. Now, okay, we already talked about a fraction bar being straight and not slumped over, right? Okay, this is a Gellerism. Never let anything hang in midair. Get a 1 under it. I do it as if something in my problem has a top and a bottom, numerator and denominator, everything else in my problem has to have a top and a bottom. Okay, now this is in English a problem involving multiplication of fractions. Thank you. Right, multiplication of fractions. What do you do first? Again, visualize those arrowheads. I can. No, before that I can simplify. Come on, how many 9s in 9? 1. How many 9s in 36?
40.
Now do your multiplication of fractions. 4 times 40 is 160. Yeah. Right. So again, if it's a proportion, visualize those arrowheads and you can simplify going this way. If it's a multiplication of fractions, you can always simplify going up and down, but you can also simplify. Again, your first 20 you should be able to do without pulling out those calculators. And notice that on that test it was number 15. But the point is, if you see a circle and a point, what are you going to think? 360. It's just every test I take, whether it's the PSAT or the SAT or the XYZ. Okay, now, problem number 60, which means it's the last one. Again, last one. What do I see? A circle with a triangle, and I also see a center of the circle, so I know it has something to do with 360. Right, volunteer to read.
As shown in the figure below, D is the center of the circle and right angle.
Wait, there's a comma. Take a deep breath. D is the center of the circle. Okay. Continue.
And right triangle. Triangle ABD intersects the circle at C and F. Point C is the midpoint of BD, which is 12 centimeters long. The shaded region inside the circle and outside the triangle has an area of 32 square centimeters. What is the measure of angle A?
Okay, go back to what we were doing, comparing the ACT requirements with the state of Ohio requirements. I'll have some time savers, and I'm also going to hand them out to you. And one thing I want you to know, every time ACT gets long-winded and has 6, 7, 8 lines of writing, so often they are just describing their picture. And so don't think, oh my goodness, this is such a difficult problem, because it's got 6 lines of writing. It doesn't even have 6, it has 5.5. Anyway, usually they're just describing their picture, so you can get most of what you want from looking at the picture. Okay, but go back. First of all, they do tell us that it is a right triangle. Now, jot this down. Where do I want you to think a thought? I want you to think a thought at a period, a comma, or a conjunction. So it all goes back to knowing your parts of speech. Okay, so after BD, there's a comma. Point C is the midpoint of BD. What's that mean if it's the midpoint?
It's in the middle.
Thanks. What? And if it's the middle, come on, look at the picture. What do we know if it's in the middle? If it's C is the middle. That, what's the same?
It's half the way.
What sides? Thank you. Come on. DC and?
CB.
Right. DC and CB are the same. And how much are they if BD is 12? BD is 12. 6. Right. So D is 6. And it's the what in the circle. Come on. Do you see how you're just doing one thought after another, but you all know all the thoughts? Right? Okay. So DC is 6. New thought, it's a radius, right? So if the radius is 6, what's the entire area? Area of a circle. Pi r squared. 6 squared is 36 pi. So this whole thing, see, there's not a thing here you all can't do. Not one thing. So 36 pi for the whole thing, right? This part is how much? 32 pi. So this piece right here is? Gorgeous. Come on, say it. You said it. 4 pi. He did 30, excellent. He did 36 pi, take away 32 pi, and he had left 4 pi. Okay, here we go again. So this piece is 4 pi out of 36. What's 4 over 36? 1. 1 what? 4 over 36. See it. Say it. 1/9. Right. So the area of this is 1/9 of this. So this angle is 1/9 of 360. What's 1/9 of 360?
40. Oh, 1/9 of 360.
1/9 of 360. Right. We're doing 1/9. Do you see why they love 9? Because it goes into 360 so nice. Okay. So 9 into 360, you already said it, 9 to 36. So this angle is 40. So this angle up here has to be 50. Yeah. And there's nothing that you all can't. First of all, it's realizing that when ACT gets long-winded, it doesn't mean that the problem, yes, the problem had a lot of steps, but there was nothing you couldn't do. You go up to a comma and you think a thought. Midpoint means that 2 equal parts. And they told you, and grammatically this is telling you, this whole thing is a clause acting as an adjective. It's describing BD. Well, you knew that from your reading skills, which is 12. So if BD is 12 and C is the midpoint, this is 6. And it's the radius. Whenever you have overlapping figures, you want to find something that they share, something that's the same. So this triangle overlaps this, so the radius is 6, so the whole area is 36. And this part was 32, so this part is 4. 4 out of 40 out of 360. Get him, and then get him. Those were all basic. A picture is worth 1,000 words. Here's a 45, 45, 90 right triangle. I've got my 90 here, my 45's here. All you have to do is, in English, you're standing here, and it's poking you in the tummy, and you look across. So that's why this leg is opposite the 45. You're standing here. It's poking you in the tummy, and you're looking across. So whatever he is, he can be an A, he can be 10, he can be 50, he can be 2,500. The hypotenuse in English is always whatever he is times, what kind of 2? Square root of 2. That's all you have to know. You multiply whatever he is by the square root of 2 to get the hypotenuse. How do you undo multiplication? Division. So you would divide by the square root of 2 to go backwards. And you need your 45, 45, 90, and 30, 60, 90 on this test. And then okay, now in a 30, 60, 90, again, a picture is worth 1,000 words. You're standing here, the 30 degrees is poking you here, and it can be up there. I mean, these could be reversed, it could be upside down, whatever. But you want to always orientate yourself, so this is poking in the tummy. You look across, and this is some variable, so it varies, it's some number. In English, we had this before, and you were the one that gave us this. What do you call this in English? What have you done to the 30 side? In English, you have doubled it. Isn't that's the math, but isn't the English you've doubled it? Sure. And then picture's worth 1,000 words. What have you done to your 30 side? Introduced, multiplied by the square root of 3. And so anything they give you, if they give you the hypotenuse and they want to go backwards, you'll divide by 2. You doubled it to get there, undouble it, divide by 2. Here you've multiplied by the square root of 3, divide by the square root of 3. That's all the 45, 45, 90, and 30, 60, 90. And yes, I mean, there's certain things are going to be on the test. Okay. Cubes. You know what a cube is? A block. Okay. Each having a side length of 0.5. I'd rather you do it as a half. Okay. So you got blocks. And you're putting them together to form a rectangular solid, and it's got 8 layers. Think of a layer cake. 8 layers. It's going up. Each layer has 6 cubes in it. So draw 6 cubes in a row. Draw 6 cubes in a row. This is number 59, and everybody here can do this problem. But you've got to get to number 59, which means the first 20 you've got to practice and practice. And yes, there'll be different questions, but they'll still be similar. Okay. And they want the volume. Everybody write down the formula for volume. You've had it since 5th grade, 6th grade. Volume equals length times. Sure. Okay. Here are my cubes. I'm making them 2-dimensional. They should really be 3-dimensional, but that's all right. Okay. Well, I'll make my first one 2-dimensional. Whoops. Okay, there's mine. Can you tell what I got in art at Walnut? Okay. So the side here is a half. This one is? They're all the same. A half. And. Thank you. And. So what's the length? Right, 3. Okay. There's your length. A half. Okay. What's your width? You just got this cube sitting here. What's its side? A half. And now, stacking it 8 high. What's 4? What's a half of 4? 2 times 3. It's all the problem, and that's number 59, gang. You all can do it. You all can do it. Again, it's got a cube. Side length is 0.5. You can do it as 0.5 if you want. And they form a rectangular solid. That just means a box. 8 layers. You know what a layer in a layer cake is. Isn't any different. 6 cubes. And all they want is the volume.
Oh, man.
Right. That's all it is. Now, we're not going to do this one, but again, translate it to English with me. They want you to double the thing in the parentheses and then add 5. Beautiful. If you see an F, they're going to double and add 5. And it did say to get a 24 to a 27, you need to be able to work with cube roots. And what does the cube root mean? How do you simplify it? I think of this as, well, if you want, you think of it as you can walk one out. This is like a roof, ROOF. And so all this is telling you for every 3 of some number, you can bring one out. Okay, so 27 is what times what times what? And remember I said, what is this? Writing it, how many times? 6. Okay. So now simplify it. For every 3 under here, I can bring one out from under the roof. So they're gone. How many do I have here? I've got 3, so I can bring one out, and another 3. So 3RR is really 3R squared. Sure. And that's and so that's A. And that's number 4. You all can, if you think with the, that you write something, it's just shorthand if you've got 6 R's down there, R, the shorthand version would just be R to the 6. All you're doing is stretching it out and then taking them out of, so they could put a 4 in there if they put a 4 in here. Then how many do you need to bring one out? 4 under the roof, you would write one on the outside. That's all it is. And if you have any left over, you have to keep them on the inside. Yeah. So if I had 6, all right, if I have 6 R's, I need 4 of them. So I'd have 1 R on the outside, and how many would be left on the inside? 2. Yeah, that's all it is. Well, he should be smaller. Right, that's, just think of it as a roof or a cage or whatever, and you're bringing one for every certain number, and that's what it said down there. Geometry, yay, okay. And by the way, on the SAT, the ACT is still 25% geometry in the math. SAT, they've reduced it to 10%. So, right. Please find number 7, because the minute they tell you AB equals BC, I want to see those slash marks. Should be number 7 in your... So this guy's 70, and this is A, and this is C, and this is B. And the minute they tell you that AB equals BC, your math teacher shouldn't have let you out of the room without you marking those. And after you mark those, what else do you mark? What am I marking? If 2 sides are equal, then the angles are equal. See, that should be like, you know, when you go to the doctor and he hits you on the knee and it's a reflex motion because your knee sticks out and goes back. Same thing, it should be a reflex motion. You should just immediately, the minute they tell you that 2 sides are the same, you mark the 2 sides the same, and then you also mark the 2 angles the same. And by the way, in English, what kind of triangle is that? Thank you, isosceles. Right. Okay, so now go back. You got a 70. Come on, number of degrees in a triangle is 180. You got a 70. 180 minus 70 is 110. Half of 110 is half of 110. Thank you, 55. Right. Do you see, you don't need a calculator for every little thing. And again, problem 15 is within those first 20, and you've got to be doing them as quickly as possible. You want to find more time to do the last 20. Right. And that was number 7. And all they wanted was BAC, which would be the same as BCA. Now, parallel lines. And I kid you not, I think of telephone pole and telephone wires, which you don't see that much anymore because most wires are now underground. But anyway, think of a telephone pole and think of the telephone wires. And whenever I do that, in other words, you need to know what angles are equal. So whenever I see parallel lines, I think of birds. Now, if they are in the same position, the angles are equal. So now describe. Here's your telephone pole. To the left of the pole, above the wire, is one bird. To the left of the pole, above the wire, is another bird, and they're equal. So your 2 angles are equal, and that's the way you can always do it. So if you have a straight line, and just think of birds, that's what it reminds me of. Okay, whoops. I want to going that way. Okay. Okay, so here's one bird. It's to the left of the pole and above the line. Left of the pole and above the line. So those 2 are equal. Now, suppose you had do you all know what a sloth is? That's that animal that, okay, and they hang upside down. So to the right of the pole and hanging upside down, to the right of the pole and hanging, and that's how you can always get a pair of equal angles. Just think of birds perched on those wires. Are they cute? Okay. Okay, volunteer to read.
The 5 congruent circles shown in the diagram below have their centers lying on the same diameter of the larger circle. Each circle is tangent to 2 other circles. If the area of each small circle is 4 pi square units, what is the area in square units of the larger circle?
Okay, so undergoing what they want first. What is the area of the larger circle? And to find the area of a circle, you need a what? You need a what? Radius. So draw the radius of the large circle. Put a point in the center, and it's going to look, your radius is going to be from here to there, right? Right? Yes. From here to here. Now, describe that to me in English. Here it would be the what of this circle? Gorgeous, gorgeous, gorgeous. Come on. So diameter and then diameter and then. Now, write that down. Whenever I do figures, draw math with figures, I do a plan first. So it's a diameter, and a radius. Okay. So there's your mission in life. You've got to get the diameter, and the radius. Now, you've got to take the given information and come up with the diameter. Well, it has a comma if the area of a small circle is 4 pi. If the area is 4 pi, how did they get 4 pi?
They did the diameter times pi.
The radius squared. So what was the radius if when they squared it they got 4? 2, right? So the radius is 2. Write it down. R equals 2. Come on, move it. So the radius is 2. What's the diameter? 4. Okay. So this is 4. And that's 4. And 4 and 4 is 8. And this we only needed to go 2. So 8 and 2 is? So what's the radius of the big circle? 10. So what's the area of the big circle? Yes. Excellent. And that's number 44. You all can do them. Don't worry about the couple from pre-calculus or something. There's 60 problems, and they say 4% of the 60 has to do with trigonometry or something, or maybe it's 7% of, yeah, it's 7%. All right, I have 60 problems. 7% of that. That means 4.2 problems. Four problems out of 60. Forget them. Worry about the other 56 problems. Good thing I could subtract 60 minus 4 quickly. Right. But you can do that one. You just have to practice. Whether you're in music or you're in sports or you're in art, you just don't show up at that recital. You've done years of practice.